This video is for class 9 physics and we are solving numerical problems from exercise 4a, and this is the part 4 of the video. Is the part 4 of the videos, right? Now in the previous part, that is part 3, we had completed till number 10. Now we are supposed to start from question number 11. Let us go to the question. The diameter of neck and bottom of a bottle are 2 cm and 10 cm respectively. So the bottle here will be somewhat like this, where this is the neck and here this is the bottom, right? The diameter of the neck is 2 cm, whereas the diameter of the bottom is 10 cm. Okay, now the bottle is completely filled with oil, right? It must be filled with oil. Now there is the situation: if the cork in the neck is pressed with a force of 1.2 kgf, here suppose, right, is pressed with the force of 1.2 kgf, what force is exerted on the bottom of the bottle? What force is exerted on the bottom of the bottle? So that is our question. Name the law principle you have used to find the force in part A. Okay, this I think you can guess it should be Pascal's law, right? The only law and principle we have studied in the fluid pressure. Now let us go to the solution of number 11. Coming to question number 11's solution, given diameter of the neck is given, which is 2 cm, and the radius should be 2 upon 2, which is 1 cm. Obviously you will know that radius should be equal to the half of diameter. Right now the question arises, why do I need this radius? In order to find the area, right? In order to find the area of the neck. Now using the formula of area, which is pi r square, here I am using r1 because r1 will suggest the radius of the neck. So replacing the values, I am getting pi into 1 cm into 1 cm. I am not solving it right now because it might get cancelled. Then the diameter of the bottom is given, which is 10 cm. So the radius of the bottom should be half of that, which is 5 cm. Area of the bottom, A2, right? Previous area was A1, will be equal to pi r2 square, the new radius. So pi multiplied by 5 cm into 5 cm. I haven't cancelled here also because it might get, sorry, I haven't multiplied here also because it might get cancelled. Force on the neck F1 given to us is 1.2 kgf, right? Now force on the bottom F2 is question mark. We are supposed to find this. Now why did I take this as F2? Why did I take this as F1? Because F1 is the smaller force, if you remember, and I've taken the area of the neck as A1 because A1 is the smaller area. Now using the expression for the principle of hydraulic machines, F2 upon F1 should be equal to A2 upon A1, and then replacing the values. F2 I am supposed to find, F1's value is given, then A2 here, right, and A1 here. Now you can see pi and pi is getting cancelled, centimeters are getting cancelled. So ultimately when I do the multiplication and then cross multiplication, right, this multiplication, cross multiplication, multiplication, I am getting 30 kgf, and number B, as we had guessed already, which is Pascal's law. Now going to the next question, which is question number 12. Coming to the next question, which is number 12, this is for your homework, right? So do it by yourself. That is number 12. Then we can go to number 13, right? Number 13 reads as: two cylindrical vessels fitted with pistons A and piston B of area of cross section that is 8 cm square and 320 centimeter square. So obviously piston A is smaller, so this will be my A1 smaller area, and this will be my A2 which is a bigger area. So respectively are joined at their bottom by a tube, and they are completely filled with water. When a mass of 4 kg, here mass is given, not the weight, neither the force, is placed on piston A. So with the help of this mass I am supposed to find F1 then, right? Smaller force. Find the pressure on piston A, the pressure on piston B, and the thrust on piston B. Okay, that is F2 here. Okay, a slightly different problem because here they are asking us pressure. So let us try to solve this. Coming to the solution of number 13, given first area, that is the smaller area which is A1 equals to 8 centimeter square, and the larger area of piston B is 320 centimeter square. So mass on piston A was 4 kilogram. So obviously the force will be 4 kgf, right? Because if I put a F here, it will change into weight. Therefore pressure on piston A will be F1 by A1, right? F1 upon A1. Then replacing the values of force and area, we're getting the answer of the pressure as 0.5 kgf, kilogram force per centimeter square. See, this can also be converted into Newton, and then we can solve it. Okay, in that case my unit would have been Pascal. Okay, but since they haven't asked the pressure in the SI unit, so I am keeping the unit as it is to match the answer with your book also, right? You could have done changing the force and then finding the pressure in Pascal. That would also be right. Okay, now we can go to question number B, which says that I'm supposed to find the piston B's pressure. So according to Pascal's law, pressure exerted on both the pistons should be same. Therefore pressure on piston B also should be 0.5 kilogram per centimeter square. Yeah, kilogram per centimeter square. Kilogram force per centimeter square. Now coming to the last question, which is question number C, let the thrust on the piston B be F2. Okay, bigger force, bigger area. Now F2 upon F1 is equal to A2 upon A1, because this is the expression from where we can calculate F2 from the principle of hydraulic machines. Then again replacing the values and doing the cancellation. Here cancellation I don't want to explain you right now, because I think you are mature enough to cancel this kind of fractions. So the final answer will be 160 kgf. Okay, this is how we are supposed to do number 13. Now let us go to the next question, which is question number 14. The last question from exercise 4A is your homework again. Right, please try to do it by yourself. Okay, this much for this video. Thank you so much.